This video is over chapters 4 and chapter 5. Chapter 4 is the physical properties of water, and chapter 5 is the chemistry of the seawater. Some things that I've learned is there's 4 basic elements of water, which are earth, fire, air, and water. Water molecules are made up of 3 atoms, 2 hydrogen atoms and 1 oxygen atom. An atom is the smallest unit of matter that retains the properties of an element. The nucleus contains positively charged particles called protons, which those are tightly packed together with electronically neutral particles called neutrons. 3 physical states of water on Earth is a solid, liquid, and a gas. When it is a solid, it is like an ice cube, and when it is gas, it's like water vapor. When water changes, it is said to change its state. This is possible because it adds or loses heat. Density of pure water is often determined at 3.98 degrees Celsius. When salts are dissolved in water, the density of the water increases. The reason for this is because salt has a greater density than water. Fresh water and salt water both transmit energy. This is in the form of heat, light, or sound. 3 ways heat energy can be transmitted within a material is conduction, convection, and radiation. Conduction is a molecular process. Convection is a density-driven process in which heat material moves and carries its heat into a new location, and radiation is the direct transmission of heat from its energy source. Ionic bonds are easily broken in water because of the polar nature of the water molecule. When salts are added to water, the salts dissolve. Concentration of the dissolved constituents in the seawater can be expressed by weight, volume, or in molar terms. The total quantity of dissolved salt in seawater is known as salinity. The average ocean salinity is approximately 35%. 6 ions make up more than 99% of salts dissolved in seawater. Original sources of sea salts include the crust and the interior of the earth. The chemical composition of Earth's rocky crust can account for most of the positively charged ions found in seawater. Sodium is moderately abundant in freshwater, but is so high soluble in seawater that it remains dissolved in the ocean. Photosynthesis is when oxygen is generated. Distillation is the process of obtaining fresh water from salt water. There are 3 ways that they can do this. A change in the state of the water from a liquid to a solid or a liquid to a vapor. Ionic exchange columns, and using a semi-permeable membrane. Some things that I found interesting between these 2 chapters are that atoms and molecules in any gas, liquid, or solid are always in motion. The average density of seawater is at 4 degrees Celsius. Tests show that the most abundant ions in today's rivers are the least abundant ions in the ocean water. Seawater transmits or conducts electricity because it contains dissolved ionic salts. The more ions in the solution, the greater the conductance. Burning of fossil fuels and deformation has led to a dramatic increase in the concentration of CO2 in the atmosphere. Since 1850, the concentration of CO2 in the atmosphere has increased 280 parts per million to 390 parts per million. Recently, the average rate has increased to 1.5 to 2 parts per million per year. About 30% of the world's table salt is extracted from seawater. What I would like to know more about is in the liquid state, bonds between water molecules form, break, and reform. Each bond lasts only a few trillionths of a second. I would like to know how. When water is heated, energy is added and water molecules speed up and move apart. How is that done? 3 questions I have for you guys is 1. Sound travels farther and faster in seawater than air. How is that possible? To me, that just sounds unreal. 2. How does the ocean play a role in regulating the oxygen balance of Earth? And 3. Is there ever a time that water molecules don't speed up and move apart? This concludes chapters 4 and chapter 5.